Hello, welcome to this video looking at limits at infinity, limits as x approaches infinity or negative infinity. And in the previous video, we just did an introduction and saw that it can be used to find horizontal asymptotes. In this video, we want to dig deeper and look at some more examples. The particular category of functions we're going to be looking at are called rational functions. They are when you have a polynomial divided by another polynomial. And so here's an example. We have numerator is a quadratic and denominator is also a quadratic. What I'm going to do on this slide is show you how to find the value algebraically. At the bottom of the slide, though, I'm going to show you a shortcut. We should be able just to look at this and know exactly that the answer is 3/2. Okay. The reason why I go through the long way so you can appreciate the shortcut, and the shortcut doesn't always work, and so I want you to know how to find limits when you at infinity when you don't have the ability to use the shortcut. All right, so here's what you need to do. You need to be able to look at the numerator, look at the denominator, and focus all your attention on the highest power of x in the denominator. And let's call that p. For us in this question, p is equal to 2. All right, here's what you're going to do. You're going to multiply by the reciprocal of x to the b, x to the 2. The reciprocal of that, 1 over x to the 2 in this question. Why do that? Well, what you want to do is create a bunch of functions, individual, that end up going to 0. And we saw in the last video, any constant divided by x raised to any rational power is going to go to 0 as x goes to infinity, even as x goes to negative infinity. So we're going to incorporate that by multiplying both numerator and denominator by this factor. Watch what happens. We distribute across, and the first term is a 3 in the numerator, and then we have a minus 1 over x, and then a plus 4 over x squared. Denominator, we have a 2, and then a plus 5 over x, and then a minus 8 over x squared. We've created these 4 terms, 2 in the numerator, 2 in the denominator, that are just going to go off to 0 as x goes to infinity. So the limit is just going to be 3/2. We should have known that already, though. And so here's the shortcut. The shortcut is that if you have a rational function and your degree of your denominator and numerator equal each other, then what you do is focus all your attention on those terms' coefficients. So that highest order exponent term is called the leading term. And so it doesn't have to be leading because it's first. It's leading because it's going to be the one that dominates as x goes to infinity. And so you focus your attention on the coefficients of those guys. Even if I jumbled up the order, it doesn't matter. The coefficient 3 in the numerator, coefficient 2 in the denominator, that's going to be the end result, 3 over 2. When your degree of your numerator equals the degree of your denominator. All right, great. So here's the second example. Same algebra. Focus your attention on the denominator. The leading exponent is a 3. The highest power is a 3. So you're going to multiply top and bottom by 1 over x to the 3. This time, something different happens. You get the same action, though. You'll get a 1 over x and then a 4 over x cubed. And then you'll have a 1 over x and a 1, and then a negative 1 over x cubed. All those terms that are in that format are going to go off to 0. Your numerator is headed to 0. Your denominator is headed to 1. This doesn't matter if you're going to plus or minus infinity. This will happen. And so this limit is 0. What was different about this one than the last one? The degree of the denominator was more than the degree of the numerator, or said opposite, the degree of the numerator is less than the degree of the denominator. In this case, what will happen is basically the denominator is growing faster than the numerator. It's going to go off to 0. It doesn't matter whether you're going to x, whether x is going to be headed to infinity or negative infinity. It doesn't matter. The result is going to be 0 whenever your denominator grows faster than your numerator. And so you'll always have, for this type of function, the x-axis as an asymptote. All right. Okay, great. So then the last possible case would be the other way around, right? Where your numerator degree is more than your denominator degree. And that's the case where no shortcut is available for you. You can't just look at the powers and be able to spit out an answer. And so I show you the algebraic ways so we can approach the next one. We have x cubed minus 2x squared plus 3 on top of 5 minus 2x squared. I'm looking at x goes to infinity. You can't plug in infinity. Don't do that. Okay? So we attack it by looking at the denominator. Highest term in the denominator is x squared. Multiply both top and bottom by 1 over x squared. I guess you could do 2 over x squared for some reason if you wanted to do that. All right, distribute. Now your numerator has an x term, and then those types of terms, minus a 2 and plus a 3 over x squared, minus 2 over x and a plus 3 over x squared. Denominator has a 5 over x squared and then a minus a 2. Those terms that look like that format of k over x to the p, they're going to go to 0. What are you left with? You're left with x over 2. Oh, I'm sorry, x over negative 2. So there's like a combination of things going on here. You do this algebra, you get to this point. And now it depends on what are these coefficients, whether they're positive or negative. It depends on whether you're going to plus or minus infinity. It depends on whether you had an even or odd power of x remaining. So I say all that to say that, well, let's conceive of a billion. If you plug in a billion divided by negative 2, cut in half, but multiplied by negative 1 is a negative a billion. So negative half of a billion, still large, and you can get larger and larger. So basically, you're not plugging in infinity, but you're thinking of a large number and trying to see what happens with that large number as x gets even larger. And so this limit is negative infinity. And so what happened here was that we had degree of the numerators more than the degree of the denominator. And so the limit is going to be either infinity or minus infinity, and it's based on 3 factors. I said them really fast. Now I'm going to put them down here for you. What really mattered in there was that the fact that we had these coefficients here, and they have their own signs. Like the top leading coefficient is a 1. The bottom, I guess it's just the constant term, is a negative 2. The coefficient on that, the highest order term, was a negative 2 in the denominator. So the leading coefficients, they matter in the in this figuring out is this plus or minus infinity. The leftover power matters. What if x was going to negative infinity and it was in the result down when you got to canceling out the terms that went to 0, you had an x who was cubed. Then the answer is going to end up being different because you're taking a negative number and cubing it. So we have to worry about the leftover power of x. In this case, on the next slide, I'll do this exact same example, and I'll go towards negative infinity. And we'll end up with a different result based on that letter B there. And then what also matters is the whether you're going to plus or minus infinity. So this is going to infinity. You'll get one answer. Not going to say that it's always going to be different as you go towards negative infinity, but that's what's going on here. The end behavior of this particular function as x goes to infinity is that it dives down, it falls. But as x goes to negative infinity, we're going to see that it rises. This function goes to infinity as x goes to negative infinity. Okay, so take these 3 factors into account. Still do the algebra. When you get to this point, after you've canceled out those terms that go to 0, then factor in these 3 different ideas to help you figure out, is it infinity or is it negative infinity? Okay, so let's switch this up and let's make x go to negative infinity. Same algebra. Okay, we arrive at the same point. And now, instead of thinking of a billion, it's now negative a billion. And it's divided by negative 2. And that's a positive, 500 million. And so you have, and the bigger the number gets, the bigger, the result gets. And so this one's infinity. So you got to take all those factors into account. The coefficients on the leading term, numerator and denominator, here it's a 1 and a negative 2. The exponent on the surviving power of x. And are you going to plus or minus infinity yourself? All those will help you figure out, is the result plus or minus infinity. Okay? All right, thank you for watching. This video is getting kind of long. I don't want to go past 10 minutes. My name is Nakia, and thank you for joining me on this journey. If you need any questions, if you need any help, just reach out to me. Comment down below, like and subscribe. I'll see you in the next video. Thanks.